over the end. He's filming for the virtual kids, you guys. I'm putting my finger over the end of the opening so that no air can escape out of the syringe. Okay? As I press on the plunger, you're gonna see what happens to the marshmallow. I'll walk around to all your tables in a minute. Okay? And then if I push the plunger all the way down and then trap the air so there's not a lot of air inside the syringe, I can pull up on the syringe and something else happens to the marshmallow. Okay? So as I'm moving the plunger in the syringe, no air is escaping. I don't know if y'all can see, but there's steam coming out right now. Okay? So off the bat, what is one of the properties that I know that I'm changing right now? How do you make a liquid to a gas? What do you have to do? Not burn it. What am I dealing with? Pressure, volume, temperature? Temperature, okay? So I'm gonna take this flask off of here, and I'm gonna place the balloon over the opening. Okay, this way no air will be able to escape. Okay. So what's happening to my temperature right now? It's increasing, right? It's currently over the flame, so the temperature is increasing. Okay. What's happening to my balloon right now?
It's getting air.
So what's changing about it? The pressure, the volume, the temperature? The volume of the balloon. Is it increasing or is it decreasing? It's increasing. Well, for this one, we're just looking at temperature and volume, okay? Because as I'm heating up the air molecules and the water vapor molecules, what happens when I increase the temperature? What do those particles do? They move around faster, right? And they want to spread out, okay? So as they spread out, my volume is increasing, okay? I'm now gonna take this flask and I'm gonna put it in this ice bath. So what's gonna happen to the temperature? When I move it to the cold, the temperature increases or decreases? Decreases. What do you think is gonna happen to the volume of the balloon? You think the volume's gonna increase? Decrease. This is hot. Can y'all see what's happening to the balloon? Did y'all see what happened? So the volume decreased so much that it got sucked into the flask. Okay, I'm gonna walk around so y'all can see that better. Okay, so for this demonstration, I put a little bit of water in the bottom of the Dr. Pepper can, and I'm heating it up. Okay, so just like the last one, we're gonna wait until this boils and we can see steam coming out. Okay, so right now what's happening to the molecules inside of my Dr. Pepper can? They're starting to move faster. Is there a way we can describe that using more scientific terms? What do we call like movement? Kinetic energy. So as I'm increasing the temperature, I'm increasing the kinetic energy of my molecules inside the can, right? They're moving faster, okay? Once this boils and there's steam coming out, what's gonna be inside my can? Well, Probably not air molecules. What is steam? It is a gas. It's the gaseous form of not oxygen, but what liquid's in here? Water. So water vapor, right? The gaseous form of water, okay? Once that starts steaming, my can's gonna have a tiny bit of liquid water, and it's mostly gaseous water, okay? I'm then going to flip the can over into this ice bath, and then y'all will see what happens.